The James Webb Space Telescope, JWST, has changed the course of astronomy with one of the most astonishing accomplishments in space exploration. Scientists using JWST have captured the first actual image of the inside of a black hole, a feat previously thought impossible. This monumental achievement is not just a technological marvel, it is a profound shift in our understanding of the cosmos. This image comes from the center of galaxy M87, a giant elliptical galaxy located about 53 million light-years away. What makes this discovery even more incredible is how scientists were able to see through the layers of matter and radiation surrounding the black hole to glimpse its inner regions. Until now, the concept of photographing inside a black hole seemed like a scene from science fiction. But now, it's a scientific reality. This wouldn't have been possible without international cooperation and cutting-edge instruments. The JWST used its advanced infrared capabilities, combined with data from the Event Horizon Telescope, EHT, to create a never-before-seen visualization. The coordination of multiple telescopes across the globe, working in tandem like one enormous eye, gave researchers a powerful tool to analyze black holes. For decades, black holes have been defined as regions in space where gravity is so strong that nothing, not even light, can escape. They are made of dense matter packed into a tiny area, creating an extreme distortion of space and time. Black holes are often surrounded by plasma clouds, which glow with intense light and heat as they spiral into the event horizon. The new image reveals a dark center, known as the black hole's shadow, encircled by a glowing photon ring. This ring forms when light bends around the black hole's gravitational pull. The brightness and shape of the photon ring offer insight into how gravity behaves near a black hole, confirming Albert Einstein's general theory of relativity once again. According to Dr. Chi-Kwan Chan from the EHT team, this isn't just a photo, it's a measurement tool that allows us to test the laws of physics under extreme conditions. Many scientists believe we are just beginning to scratch the surface of what these new images and data can reveal. Researchers are now applying PRIMO, Principal Component Interferometric Modeling, a machine learning tool that enhances the quality of images obtained from EHT. PRIMO helps reconstruct the most accurate visual representation of the black hole and can be used in analyzing other observations, including the supermassive black hole at the center of our Milky Way, called Sagittarius A. But this historic image is just the start. The James Webb Telescope has also uncovered something equally fascinating: the oldest active black hole ever observed. Named CERS 1019, it exists in a galaxy that formed only 570 million years after the Big Bang. This black hole weighs about 9 million times the mass of the Sun, making it one of the lightest observed in the early universe. What puzzles scientists is how such a massive object could form so quickly after the universe's birth. Typically, black holes gain size over billions of years. This discovery suggests that supermassive black holes might grow much faster than previously thought. It could mean our current models of black hole formation need to be re-evaluated. Astronomer Rebecca Larson from the University of Texas at Austin noted, "This is like seeing the seeds of a cosmic giant before anyone expected him to exist. It's mind-blowing." Her team was also responsible for spotting 3 black holes from 1 to 1.1 billion years after the Big Bang, plus 11 early galaxies, a testament to the telescope's powerful capabilities. These findings were published in the prestigious astrophysical journal Letters, showcasing their impact on the scientific community. Each paper reveals pieces of a puzzle that has stumped researchers for generations. How do black holes form? How fast can they grow? What role do they play in the evolution of galaxies? Interestingly, the black hole in CERS 1019 appears to be actively feeding. It's surrounded by an accretion disk, a whirlpool of gas and dust spiraling inward. This disk glows brightly, and material sometimes gets blasted out as twin jets near the speed of light. These jets produce intense radiation, helping scientists study the environment around the black hole. Professor J. Han Cartelope from the Rochester Institute of Technology suggests that a galactic merger might be fueling this black hole's activity. Such events can stir up material and trigger star formation, providing both fuel and chaos for growth. This is still under investigation, but the possibility of black holes forming in this way opens new theories in galactic evolution. While CERS 1019 captured attention, it's not alone. The JWST also observed a black hole in galaxy GNZ11, which set a record with a redshift of 10.6, meaning it existed just 400 million years after the Big Bang. The presence of black holes this early implies that black hole seeds began forming almost immediately after the universe's birth. Astrophysicist Hannah Ubler of the University of Cambridge says this changes everything. We're seeing the architecture of the early universe, and black holes are part of that structure. Her team is investigating how superheated gas interacts with these early black holes, which may shape how entire galaxies behave. By studying the radiation emitted by these ancient black holes, researchers are trying to measure the growth rates of their host galaxies. Black holes don't just consume, they influence everything around them. Their magnetic fields, radiation pressure, and gravitational forces mold the cosmic landscape in ways scientists are only starting to understand. Dr. Stephen Finkelstein, leading the CERS program, added, "This is the beginning of a revolution in astronomy. We now have the tools to see and measure things we could only dream about a decade ago." The James Webb Space Telescope continues to make discoveries that shift the foundation of astrophysics. With each observation, it provides deeper insight into the earliest epochs of cosmic history, offering not just visuals but quantitative data that will be studied for years. The question now is, how far can we go? Can we one day witness the birth of a black hole in real time? Could we learn how these cosmic giants influence dark matter or the expansion of the universe? These are no longer questions for science fiction, they are the next steps in scientific exploration. Scientists agree that we are living through a golden age of astronomy. With the Webb telescope and tools like EHT and PRIMO, humanity is reaching into the unknown. Dr. Roger Blandford, a prominent astrophysicist from Stanford, says, "Every new dataset from JWST opens doors to realms we didn't even know existed. The sheer depth of its findings is astounding." The James Webb Telescope isn't just about black holes. It's also studying exoplanets, stellar nurseries, and the composition of ancient galaxies. These simultaneous missions mean that while we uncover the mystery of black holes, we're also learning how stars are born, how planets evolve, and how life might begin elsewhere. Perhaps one of the most fascinating parts of this journey is that we're seeing not just what the universe is, but how it became. These findings may help answer the deepest philosophical questions about our place in the cosmos. All these discoveries come from a telescope orbiting 1.5 million kilometers from Earth, in a region of space known as the second Lagrange point. Its remote location ensures it remains cold and stable, perfect for collecting faint infrared light that has traveled for billions of years. As this technology continues to evolve, we can expect even more stunning images, groundbreaking data, and transformative ideas. It's a thrilling time to be curious. Subscribe to our channel and thanks for watching.